Question 2, assignment 3. It states that show that the system x plus 2y minus z is equals to A, 2x plus y plus 3z is equals to B, x minus 4y plus 9z is equals to C is consistent when C is equals to 2b minus 3a. The first thing that we need to ask ourselves is, what does it mean when we say a linear system is consistent? A linear system is consistent when it has at least one solution. In one of our videos that we did when it's been uploaded on YouTube, we have explained the principles of when a system is consistent and when a system is non-consistent. We have also explained the fundamental principles that they are supposed to watch for when a system has got one solution, many solutions, or no solutions at all. When a system has no solutions at all, which means it is non-consistent, you will have a situation where you have 0 is equals to a real number. For instance, you are going to have 0 is equals to 1 or 2 or 3, any real number, which is not true. So for a linear system to be consistent, 0 can never be equal to any real number. So in this linear equation, the linear system, the first thing that you need to do is you need to turn this linear system into an augmented matrix. You can work it using an augmented matrix, or you can just use the linear equation, the elimination method. However, I would prefer us to use the augmented matrix or the augmented matrix route. For you to turn this linear system into an augmented matrix, I also refer you to an augmented matrix video tutorial that we did and was uploaded on YouTube on how you can turn a linear system into an augmented matrix. In this instance, we are going to have 1, 2 coming from here, 1 coming from here again, then 2 coming from 2y, 1 coming from plus y, 1 minus 4 coming from minus 4y, then minus 1, 3 coming from here, 9, then we're going to have a coming from here, b and c. So we've successfully converted our linear system into an augmented matrix. Then we are supposed to turn these 2 and 1 into zeros, so that we are supposed to turn these 2 into 0, so that we can going to have 0 here and a 0 here. And how are we going to do that? We're going to have the first equation, we're going to have the second equation, 2, 1, 3, b, minus 2 times the first equation. So minus 2 times 1 equals minus 2, minus 2 times 4, minus 2 times 2, minus 4, minus 2 times 1, 2, minus 2 times a, minus 2a. So if you add this equation, if you add the first, this is your second row, to your first row that is multiplied by 2, by minus 2, you're going to get 0, minus 3, 5, b minus 2a. Now, this is your new equation 2. So if you rewrite the matrix now, you're going to have 1, 2, minus 1, a, then you're going to have your new second row, minus 3, 5, b minus 2a. Then your third row remains the same, c. So now you are now focusing on this 1. You want to turn it into a 0. So if you rewrite now your matrix again, we had 1, 2, minus 1, a, and we had 0, minus 3, 5, b minus 2a. Then we had 1, minus 4, 9, and c. Then we want to turn this into a 0. So we're going to have the third equation, 1 minus 4, 9c. You're going to add it to minus 1 times the first row, which is minus 1 times 1 is equals to minus 1, minus 1 times 2 minus 2, minus 1 times minus 1 is equals to 1, minus 1 times a is minus a. Then if you add them, you're going to get 0, minus 6, 10, c minus a. So this is now your new third row. So if you rewrite now, you're going to get 1, 2, minus 1, a, 0, minus 3, 5, b minus 2a. Then you're going to get now, put in your new third row, which is 0, minus 6, 10, c minus a. So now, you want now to focus your attention now. You want to turn this into a 1. You want to turn this into a 1. And you want to turn this into a 0. You want to turn this into zeros. This to be into a 1. So to turn this into a 1, you divide row 2 by minus 3. So if you divide row 2, this is your row 2, row 1, row 3, row 2, row 3. So you divide row 2 by minus 3, you're going to get 0, 1, minus 5 over 3, then b minus 2a, all this divided by the minus 3, so you get all this by divided by minus 3, get it as a minus 3. Then you want to now to turn, you turn your attention here now, you want to turn this into a 0, minus 6 into a 0. So if you rewrite the equation, first rewrite the equation, this is your new equation 2. So if you rewrite the matrix, you're going to get 1, 2, minus 1, a. Then the new equation 2, which is 0, 1, minus 5 over 3, then minus b, minus 2a over 3, then 0, minus 6, 10, c minus a. So this is our new matrix that we have. This is our new augmented matrix that we have. So now we want to turn our attention to the third row. But first, let's first write our augmented matrix. This is 1, 2, minus 1, a, 0, 1, minus 5 over 3, then you have minus b minus 2a, 4 divided by 3, 0, minus 6, 10, c minus a. So now you want now to turn this into a 0, minus 6 into a 0. So you're going to have your third row. You want to turn this 6, you want to add your third row to 6 times your second row. So if you multiply 6 times 0, 6 times 1, 6, 6 times minus 5 over 3, you're going to get minus 10. Then if you multiply 6 times minus, or in brackets, b minus 2a over 3, you're going to get, if you multiply this by 6, you're going to get minus 2, this because you're saying multiply by 6 here, so 3 into 6 is going to get 2, then you're going to get minus 2b minus 2a. Then you're now adding the entire equation. So here you're going to get 0, 0, 0, c. Now here you're saying c minus a minus, so you're saying c minus a minus 2b minus, now minus 2 times minus 2a is equals to plus, so plus 4a. So if you solve this equation now, you're going to get your new third equation as 0, 0, 0, c minus a plus 4a minus 3a, then minus a plus 4a is equals to get plus 3a, then you're going to get minus 2b here. Now you have a situation now, this is the situation you're talking about, where we're saying 0 can never be equal to a real number. So in this equation, for it to be consistent, this way you are saying 0 is equals to C plus 3A minus 2B. We are saying C. If you are going to resort this equation to solve for C, you're going to say, if you take all these items here, if you take them this side, you're going to say C is equals to, if you take this 3A this side becomes a negative, takes the 2B this side it becomes a positive. So you're going to have C is equals to 2B minus 3A. So we have successfully solved to say that if C is equals to if it is equal, if C is equals to 2B minus 3A, then the linear system is consistent.